Hello, everyone, and thank you for joining us today. Welcome to Megger's special webinar series. Today's topic is You Ask, We Answer, a panel discussion on cable diagnostics. My name is Michael Fleischer, and I'm the digital marketing specialist from Megger. I'll be acting as the technical moderator for today's presentation and supporting you on any technical issues or questions for our panel. On the right side of your screen, you will see a control panel that looks similar to this one. You can submit questions at any time during the presentation by typing in the box highlighted in red, and we'll integrate them into our discussion here today. Additionally, a certificate of attendance and link to the recording of this webinar will be sent to all attendees in 2 business days. Our host today is Shay Yaki, Regional Sales Manager with Megger. Thank you for joining us today, Shay.
Thank you, Michael, and I appreciate the introduction. I'll give a little bit more detail on myself. I've been with Megger for 14 years, and I'm currently a regional sales manager for the Northeast region part of the United States, as well as Eastern Canada. I'm one of the North American sales team leaders for the cable fault testing and diagnostic application team. I'm pleased to be your host and moderator for today. The You Ask, We Answer is a webinar series developed in response from the COVID-19 industry travel restrictions. Megger has learned from other webinar series conducted over the past few months that the industry continues to want knowledge, and therefore, as opposed to educating on a pre-selected topic, this series is to allow you, the audience, to guide the discussion directly through questions. This is the third installment of this panel discussion where attendees submitted questions during registration. We will also encourage live questions during the discussion, which we will address as time permits. The session is planned for an hour, but can go up to an hour and a half. Questions submitted during the registration have been placed in topical areas, which we will discuss shortly. And we will address as many live questions as possible during the appropriate topic. A panel of experts from Megger and other companies will address the questions. So let's meet the panelists. The first is Don Janudis. Don presently serves as president of Halco Testing Services, a NETA accredited company. Don has authored 50 technical articles for the NETA World Journal and has featured in the Electrical Construction and Maintenance and Uptime magazines. His work has been summarized in the book, Partial Discharge and Other No Outage Testing Methods, published in 2019. Thank you, Don, for being here with us today.
Thanks, Shay. Thanks, everyone.
Our next panelist is Pat Hannaran. Pat is the Assistant General Manager at Nebraska Public Power District for the Retail Division. Started professional career at ComEd in Chicago, where he served as a senior engineer in the distribution testing equipment group with focus on underground systems and installation, operation, and maintenance of distribution networks and automatic transfer schemes. Thank you, Pat, for joining us.
Thank you, Shay.
Next up is Hein Puder. Hein started with the SEBA Megger organization in 2007. He started initially as a tech support engineer. He currently holds the role for product manager for testing and diagnostics. He is an active member of SEGRE, a working group for asset management of medium voltage cables. Thank you, Hein, for joining us.
Thanks, Shay, and good day to you all.
Next is Henning Ogen. Henning has been with the HEW Megger organization since 1998. He is currently the product manager for cable products based out of our Valley Forge, Pennsylvania office. He is a member of IEEE and also an active member of the IEEE for very low frequency testing in the field, and also guide for fault locating on shielded power cable systems, as well as the subcommittee F for field testing. Henning is the joint holder for the U.S. patent for sectionalizing power cables and distribution loops. Thank you, Henning, for joining us today. And our last panelist is Darren Byrne. Darren is the Director of System and Services for Megger NAFTA. Darren joins Megger with over 25 years of business development experience. Darren is well established in the electric utility market and has written many published white papers and articles related to the system assessment for aged and newly commissioned cables systems. He currently holds 4 patents related to the partial discharge monitoring. Thank you, Darren, for joining us.
Thank you, Shay. Hi, everyone.
Today's topics for the You Ask, We Answer cable diagnostic session will fall into the following categories: testing procedure, VLF and Tan Delta testing, partial discharge testing, analysis methods and criteria, and a catch-all miscellaneous. So let's get started on the questions. Our first question today is for Darren. What is the benefit of cable testing and diagnostics?
Thanks, Shay. Yeah, so I think that's a good question to start. It's basically to determine the condition of your system. So the system can be, either new or aged. So if we think about new systems and commissioning those systems, it's basically about finding defects before cables are put into service. So, you may have contractors putting cables into service. There's a warranty. If you can test those cables and fix those issues, the workmanship issues that could possibly happen, there's other issues that can happen too, you can get that done before the warranty runs out. So it's a little bit like having an insurance policy, if you will. And, I think the benefit of cable testing and diagnostics, with that, we probably wouldn't recommend a Tan Delta, but maybe a PD condition analysis or a withstand test. And then on the other side of that, we would have the age systems that are out there. There's a lot of problems that people have or companies have with age systems. So as I said, with news like a new systems like testing would be for like an insurance policy. With aged, it's a value-based opportunity. There's published information out there that shows that over 60% of cables will meet the standards of new cable with really minimal termination remediation. So basically what this is about, if 60% of cables are good, that are 25 years or more in age, then basically you basically can do more with less money. You can rehabilitate just that 40% that needs either a repair or replace. And with that, we would probably say don't withstand the age cables, but maybe do a PD and a Tan Delta test on those types of systems. So hopefully that answers a little bit about the benefit.
All right, thank you, Darren. I appreciate that. Up next, the next question is for Don, and it's from Timothy Connolly. The question is, procedurally, from a safety standpoint, how are companies performing live online PD testing of cables?
All right, I've worked with Tim before in the past. If you're out there, Tim, hello. So, in order to perform online cable PD testing, you have to place the sensor inside the switchgear and connect to the cable shield. So if there's live bus inside a switchgear assembly, that becomes very dangerous. If you're in an area where there's T-bodies or load break elbows, it's generally less dangerous. But certainly you have to conform with all the NFPA safety standards and regulations, perform a job hazard analysis, and wear the appropriate PPE. It might also be a really good idea if you can use an adapter for the sensor using a hot stick and maybe fiber optic or Bluetooth communication to your test set. Some other alternatives could be to reroute the cable shield outside into a separate enclosure so that you can stay outside of the switchgear when you're taking those measurements. And you could also install permanent sensors on the shields and bring them out to a breakout box where you could also obtain the signals. Permanent monitoring would be another solution. And you can always shut down before you do the test, but that sort of takes away from the whole idea of doing an online test. So if you have a lot of outages to perform an online test, then it's no longer an online test in a way, but safety first, of course, always. Thanks.
Is there any other comments, Hein?
Yes, I fully agree with what Don is telling. So it depends on the circumstances you have. So it depends on the type of switchgear, depends on the type of elbows if you are within the danger zone. So the solution which Don already gave is installing permanent sensors or rerouting the earth of your cable. So if you install permanent sensors, then you always have a way to connect to the cable and perform online monitoring without an outage. Another way, which is now upcoming, we see that mainly upcoming in Europe because they have mainly the voltage detection systems within their switchgear. So that's called VDS. It's a capacitive sensor which is integrated in the adapter of the elbow, and via that, that's also a way to couple out partial discharges. In the US with the bed mount transformers, I don't think you have it yet, but probably in the wind farm industry, those VDS, so voltage detection systems, will also be installed, and it could be another way of coupling out online PD.
Thank you.
Yes, that's correct. Yeah, we do have in our T-bodies, for instance, we have a coupling capacitor tap to measure voltage. So I think that's what you're speaking of, coupling to that permanently. Yeah, it's a good idea.
Thank you both. So our next question is going to be for Pat, and it's from Brandon Riddle. The question is, for aged medium voltage 15 to 25 kV cables, at what age and frequency would you start routine testing, if at all?
Yeah, thank you, Shay. That's a great question. From a utility user standpoint, we started our testing with our older aged bare concentric cable, and we're still working our way through that population of cables in our utility. Generally, what we've seen with anything that's jacketed is we use a VLF Tan Delta test. The jacketed cables, even back to the mid 80s vintage when we started putting those in, are testing very, very well. And to Darren's point, we're seeing about a 70+% pass rate on our bare concentric cables from the Tan Delta. So I would completely agree. Our goal would be to have a preventative maintenance plan going forward, where we do have that frequency of testing. And, we'd like to do that in the 3 to 5 year range so we can get that trend line and start to see that cable trend over time. But like I said, we're still working through our program of the population that we have. So I would certainly defer to any of our panelists for additional comments.
Okay, I mean, in a way, I think Patrick gave a pretty good answer to the practical aspect of doing testing on these older population cables. The question itself is pretty wide because it depends a lot what the history of these cables are. I think you talk about aged cables, and what was your experience with these cables? What type of faults did you experience? Many companies now start keeping log of the failures they have, and they sort them out by cable failures and accessory failures, so they have an idea what maybe the problems to expect are, and then you can tailor a testing program to that. But overall, you can say from a general point of view, at what age should you start testing? If you never did a test on your old cables, you have to start somewhere. So that is your base point. You have to establish a base point, and then you go forward, and then you can make comparisons to your base point and say, okay, maybe every 3 years, every 5 years, and that depends on many factors that are unique to your particular system that you're trying to assess. So there is not one answer doesn't fit all, unfortunately, on this. It depends on what your experience is on this. But I think it's reasonable to, once you start a testing program, to monitor the aging of the cable, the insulation aging, to retest every 5 years. But this is just a ballpark. It could be that you have to do it faster depending how quickly the aging in your system takes place, right? And it depends on the soil, it depends on the load, it depends on many circumstances. So you have to establish, some of these parameters have to be established based on the experience in your own system.
Thank you, Henny. So any more comments? Good to go. Okay, on to the next question. This will actually be for you, Henny. It's from Thomas Glory, and the question is, what is the best method to test 5 kV cables in a 45-year-old industrial plant, and what type of testing program needs to be established?
Okay, first of all, the question is, what type of I can do depends on the cable design. Now, this is industrial environment and 5 kV. So the very important aspect of it is, I hope all these cables are shielded cables, because if they are unshielded cables, then you have a problem doing any type of a meaningful dielectric test, whether it's a, you know, a change in dielectric properties, or it's a partial discharge test. If you don't have a shielded cable, basically you can only do, and that is not too meaningful. You can maybe do a hypot test to ground, but it's that doesn't tell you very much, and you can maybe look at leakage current, but the cables would have to be direct buried, cannot be on cable trace. You are in an industrial environment. I would imagine that many cables run on cable trace. So there are a lot of questions that need to be answered before I think a good answer can be given to your question, what in your particular situation is the best way, you know. And this is something, you know, if you like to pursue it, we certainly glad to talk to you about it. Like I said, we would need to have some basic answers first from you on your system.
Yeah, good point, Henning. That's exactly my thoughts as well. A lot of these older installations in the U.S., 5 kV installations, were unshielded cable, and we typically find they're discharging everywhere, and until a duct gets flooded, then they somewhat last. But how reliable is that? So I think you also have to maybe consider the design life. And so if you have unshielded cable, it's probably good to start thinking about replacing it. And but as you said, if you have shielded cable, then a different approach is proper.
Thank you both. Okay, our next question is going to be for Darren. This question is from the audience, and what are the critical success factors for aged cable testing?
Okay, that's another good question. Well, I mean, you know, it's a loaded question. It's a good question, definitely, but it depends on the critical success factors that you want to measure. Really, it does. Yeah, what I've found in the past is that when it comes to aged cable, is typically a utility will determine a scope of cable, and it's typically like an 80-20 rule, that 80% of the problems are coming from 20% of the system. And I think Patrick mentioned, you know, unjacketed cable. It might be, you know, 70s and early 80s type cable that might be causing the issue. So the critical success factors, I think, most likely the reason why you want to look at the system is because you have a reliability issue. So that comes down to reliability improvements. So you might look at things like customer minutes of interruption and how that's improving, KFE, a lot of the key performance indicators that are out there. But also, you know, we talked about 60% of the cables could actually be good. So it's also a capital management program. You don't have to replace as much cable. If you're testing and you know what is testing good, you leave there. And then you only deal with that 40% of cables that need addressing, whether repairing or replacing. So there's a capital management solution that you might look at as a critical success factor, return on investment. Resource management too. If you only have to deal with 40% of those cables, then you need less crew days to replace cable. So, you know, it could be a resource management issue that you're looking at. We know there's certainly an aging workforce across utilities in the US. And even if you have all the money in the world to do the project, you may not have all the people in the world to do the project. So it's a resource management program. And I think also, you know, you could look at a critical success factor being time to complete. You know, if you're dealing with a whole scope of cables where only 40% of it needs to be addressed, then it's, you know, you're going to have a much faster time to complete to go on to your next scope of cables. So there's a lot of critical success factors, and everybody's different in what they want to measure, and it could be a little bit or of all of what I mentioned, and there's probably more too. So.
Is there any other comments? Pat, go ahead.
Yeah, Thank you, Shay, and I agree with everything Darren said, and then that's why we implemented our diagnostic testing program here for all those reasons. But to begin with, we had to overcome the management side, right, for to dedicate the resources for a diagnostic testing program. And then once we got that in place, you have to allocate your asset management program to monitor that. And then probably the biggest hurdle for us was the field operations side, getting them to buy into the test and performance. But once they started to see results and cable replacement of the systems that they knew were those aged, older at-risk systems, now they ask for the machine, and they want it out there. So that's really been a dial for success for us.
I might want to add maybe one aspect to it, which sounds trivial, but it's not so easy sometimes to answer, and that is a critical factor is really to pick the right cables for testing, because you cannot test all cables. You must make must make certain assumptions to pick a group of cables that you test, and so there are different ways that different companies look at this, whether it's critical cables or whether it's for whatever reasons, but you must pick the right population of cable, and the other thing is you need enough tests. In the end, testing is a statistical program, so you need also enough test data to really be able to draw statistical conclusions.
Yeah, and I think also, sorry, to come up with a good rehabilitation plan based on those that need they need those defects fixed that you find.
Thank you all. All right, our next question is going to be for Hein. This is from Hella Willis, and it's, what is the low-cost best practice to initiate online partial discharge testing of cables and blending with offline Tan Delta testing?
That is a good question, but not that simple. So if the question would have been, what is a low-cost best practice to initiate online partial discharge testing of cables and the blending of offline PD testing, then I would say yes, that's a good way. So if you online screening, so online PD screening of your cables, then based on that, you can focus your offline PD testing. But making a mixture of offline Tan Delta and online PD will not be that simple, because it are two different aging phenomena. I normally compare it with going to a doctor. If you have a broken hip, and if the doctor is only measuring your temperature, then he would say you are fine, you don't have any fever, so everything is fine, but you still have your broken hip. And it's the same with a cable. If you focus on Tan Delta diagnostics, you look to the aging of the insulation. So it could be water trees in the XLPE cable, could be moisture in your paper insulation. If you look to PD testing, then you are focusing on local problems, which could be outer damage of the cable, which could be bad workmanship, which could be drying out of paper insulation. So there are different things which are not identical. So a Tan Delta is not the same as a PD diagnosis. That's why for aged cables, you basically need both tests. So if there is no PD, it doesn't mean that your cable is perfectly fine. So it could be that your cable is completely soaked and that it's at the end of its lifetime. So it's you need both. And I've seen that there will be some more questions about it, so we'll probably discuss a bit more about this topic.
Yeah, I like to. Oh yes, sir. I like to think about maybe doing the online PD testing to spot any bad failures, impending failures that might be out there, and also include your switchgear, which is part of the equipment as well. And then, as Hein said, maybe a plan would be to take some percentage of your equipment to do offline PD and Tan Delta testing, like 20% over the next 5 years, or something along those lines.
So there could be a strategy behind. So like Don is also telling, if you have a specific age of your cable, then okay, if I have lots of cables installed in the 80s, then I can do some Tan Delta testing on those cables. If the result of 80% of the cables is good, then most probably the other ones are also in a good condition. So it's also a mixture of strategy and statistics and measurement data. No?
All right, thank you both. Okay, our next question is actually a live one, and we're going to go back to you, Hein. It's from Pranav Patel, and it is, what is the best testing method cost-wise to test 138 kV cables?
Over here, it depends on what type of test we are talking about. So is it a commissioning test or an acceptance test of a new cable, or is it a condition monitoring? If we look to acceptance testing, then you normally need to test with an overvoltage, and over there, there are several ways to test your cable. Could only be a simple withstand test, but it's like with medium voltage cables, it's only a go, no-go test. So it doesn't tell how good or how bad your cable is, or if there are any minor defects. So what normally is recommended in the high voltage world is also performing a partial discharge diagnosis as part of your acceptance test. So this can be done either with resonance testing as a way, this can be done with DAC testing as a way, and nowadays also under research is VLF for high voltage cables. Also over there, they are systems available for testing those that class of cable to get an idea of how good or how bad the cables are.
Any other comments from the panelists? Okay. All right, we're going to move on to some VLF and Tan Delta testing. So the next question is going to be for Henning. This question was submitted from Joe Irk, and it says, if my station is only doing Tan Delta testing, what is the most likely failure mode that we will observe that was undetected?
Well, if you do Tan Delta testing, that means you're looking to assess the aging condition of the cable. And the aging condition is typically what we call a global issue. So, you know, the XLP or, you know, EPR cables or even paper cables, they have a certain aging characteristics independent of really outside influences. And so if you do Tan Delta testing, you get some idea about the aging characteristics of your system. What you don't get is if you have a very localized issue on a cable, which maybe have been initiated many years ago in laying the cable or installing the cable, or maybe by a production issue when the cable was made. So if you have a localized issue, typically you cannot find those localized issues with a Tan Delta test. So those are the ones you can either find with a partial discharge test, or you might find with a hyper test, depending on the nature of that defect. If it's a high resistance defect, then you probably with PD, and if it's a defect where the insulation resistance it has dropped significantly due to damage of the cable, then you would expect a high pot failure. So all these test methods that we talk about in the today, they are all good test methods, and there is not one better and one worse. It depends what it is that you need to find out, and each test method can give you an answer. And so it's obvious the more different tests you run, the more complete picture of the cable health you will get. So if you're running Tan Delta test, it's a good test for aged cable, but you know the answers are limited to what you get, and the other ones you cannot get with that method, and you have to be prepared for those type of failures, which in your case would be, you know, failures where the cable actually fails. You have a in-service failure. Yeah.
I like to think of a cable as a cable system, and that cable system consists of terminations and splices in the cable itself. So I think, as Henning pointed out, the best method for testing the cable itself seems to be, in many cases, the Tan Delta test, whereas the components, displaces, and determinations fell in a different manner, and the partial discharge test becomes a better test to detect those type of defects.
Okay. All right. Anyway, go ahead, Pat.
I would add, Shay, that just having a testing program, there's going to be some ancillary benefits that you realize as well. And that would be you're getting into equipment that you may not have gotten into for quite some time. So you're going to see some older transformers, elbows, arresters, switchgear, things that you might not otherwise enter that didn't display any issues in the past. And so you're going to find things through that inspection process as well as you go into connect and do your tests, and that provides real benefit too.
Okay. Thank you. Any other comments? All right. Next question is going to be for Hein, and this was submitted from Dennis Boyd, and it is, can VLF Tan Delta testing be performed to cable bundles when there are time restrictions?
That is a good question. So this is normally not recommended. So it's recommended to test phase by phase. Mainly, as you can then also see differences between the phases. So if you have aging, then the Tangens delta in all phases should more or less be the same. So you have a similar pattern. But what you can also see with a Tangens delta measurement are local issues. So if you have a soaked joint, or if you have some other local problem, then it could be that in one phase the Tangens delta is far higher compared to the other two phases. And if you test all three phases at the same time, you don't see it. If you test phase by phase, then you know, aha, I have one being completely out compared to the other two phases. So there is a local issue. So I need to do some further inspection. So and there are, yes, you can do it, but there are things which you can oversee. So it's an average value of your entire cable, and the longer you make your cable, so if you put three phases in parallel, the smaller you will have influences from local issues. No?
Any other comments? Go ahead, Pat.
Shay, we have run into that in our testing program where we may have an access issue or we may not be able to get an elbow off of something. So it's something we'll address, but we have bundled the cables, but just as Hein pointed out, you need to understand what that test is telling you at that point and what the results will mean when you look at them as far as bundling cable sections together. So
maybe there would be one other consideration to this is the time savings. I think could be substantial if you perform a VLF hyper test. Then and if you do a VLF hyper test, you can certainly bundle cables together, because if you had a failure, then you have to divide it up and you find which phase has a failure. For Tan delta testing, which takes much less time than a hyper test, so that the time constraints are maybe less, and but like the other two guys already said, it's pretty meaningless to run a bundled Tan delta test, because you don't know which cable is the one that really has an issue, and it might be masked even by basically adding up the results into one result. So it's not a good, I think, not a good practice.
Saw a couple hands. Go ahead, Don, first. I saw yours first. Go ahead.
Yeah, right. Yeah, so you're adding a lot of insulation into the system, but your Tan delta results are one number. So I guess if that number was really good, maybe there wouldn't be so much a concern. But then if that number is low, then what does that get you? Then you have to start taking stuff apart, I guess, and trying to find out where that bad actor is.
Hein, you had a comment as well?
Yeah, so just to talk about numbers, so what are the time savings? So if you test three phases at the same time, or test three phases individually, you're only talking about a time saving of maximum 10 to 15 minutes or 10 to 14 minutes. So it's not a lot. So it's more time setting up the equipment, getting the cable offline. That's taking more time in compared to the testing itself. So the test itself is 7 minutes per phase, and that's it. So it's not a lot of time savement. No?
Okay, thank you all. All right, the next one is actually live from the audience, and Hein, this will be for you. It's from Sanjay, and the question is, considering equipment capacitance limitations and cable lengths, Is it acceptable to parallel phases of a cable and apply withstand tests for especially the VLF and DC test?
Yeah, so over here, it's important that you know your restrictions of the equipment. So if you look to the standards, also the IEEE standard, it recommends to test at 0.1 hertz. So if you put 3 phases in parallel, and if your system can still test at 0.1 hertz, then yes, go for it. If the frequency goes down, then your test efficiency also goes down. So that can have an effect on the effectiveness of your test. So you need to be aware of what your equipment can do and what the total cable capacity is. If it is within the range of the equipment so that you can still test at 0.1 hertz, then I would recommend to do all 3 phases at the same time. That saves time. However, so this for normal shielded cables, this is true. If you look to paper cables, if you have, for example, belted paper cable, so where there is only one common screen, then testing all the 3 phases at the same time is not a good option, because you don't simulate the stress between the phases then, because you can also have a problem between 2 phases, which is then 1.7 times the operating voltage. If you then test all 3 phases at the same time, it will not help you. But I do not know how widely spread those belted cables are in the US, but in Germany, in the lower ranges, and also in other parts from the UK and in India, this is a quite common cable. This plays a role as well. So depends on the type of cable and also on the equipment limitations.
Henning, did you have an additional
Yeah,
comment?
maybe one comment, since the question is asked. You know, I think with particular capacitance limitations and cable lengths. So I would think this question is for longer cables with higher cable capacitance. I just want to mention that there is also like Hein was alluding to, a difference in the 2 VLF technologies. Typically, what's called the cosine rectangular technology for VLF testing can handle about, you know, to the tune of 5 to 10 times the cable capacitance of the pure sinusoidal technology, the 0.1 hertz sinusoidal technology. So, and if we only talk about hyper testing, then I think, you know, for long cables with large capacitance, the cosine rectangular technology certainly offers a clear advantage, because I can bundle the cables together and do the hyper test, and that saves me, if I go with a typical recommended time of 1 hour per phase on H cables, that can make it a 1 hour test versus a 3 hour test. So it would save some real time if you follow that principle. Okay, so I think, you know, technology also has to be looked at what each technology can do, and in this case, the CR, the cosine rectangular technology, is more capable to address this particular issue.
Great. All right. Thank you both. Our next one is from a registrant, and this will be going to Pat. It's from Hadam, and the question is, please elaborate on DC hypots versus VLF Tan Delta. How could we interpret results of Tan Delta? Is there a reference guide?
Yeah, thank you, Shay. Good question, and I think I'll defer to our panelists on the DC hypot versus VLF Tan Delta. From a diagnostic standpoint, we have moved away from any DC hypot testing. We will use it for fault location or to do a quick proof test to re-energize a cable. But from a diagnostic standpoint, from what we've learned over the years, we've moved away to a VLF Tan Delta. From a results perspective, you know, we follow the IEEE 400.2 and the table guide there. But for us, what our goal was to rank and prioritize the replacements based on our test results. So what we've done is we've developed a statistical algorithm that we plug the results into, and we get an output, a single number output that we can then rank and prioritize those cable replacements on. So that's worked very well for us at this point, and we'll continue to do that. So.
Any other questions or any other statements from the panelists? Okay. So the next question is going to be for you, Don, and this is from Rob Windman. And the question is, upon splice repair of a concentric neutral cable, is it necessarily indicated to VLF the cable or just IR test, insulation resistance test?
All right. Okay. So yeah, there's a couple thoughts here. One is that the insulation resistance test is usually performed at like 5 kV. So that doesn't generally stress the cable well enough for anything 15 kV and above, for instance. Maybe it'd be all right for 5 kV cable. So I think that it would be better. I also picture a failure in the cable and the urgency to get that circuit back online. But in the time constraints to do that we're faced with sometimes. But I think overall a VLF withstand test at least would be good at a reduced voltage from acceptance testing, maybe 60% of the acceptance testing level. One also has to consider, well, where did this failure occur? If it was at a splice, then maybe I wouldn't be quite as concerned with the cable itself. But if it was in the middle of the cable, then if I'd like to think about trying to do adequate testing to determine the condition of the cable, not just be in a big hurry to energize it. So maybe that failed because of water trees, and maybe I want to do a Tan Delta on that cable also, or other diagnostics. So it's I guess a complicated answer that I provided there.
Great. Thank you, Don.
Well,
Any?
maybe I
ahead,
would
Henny.
like to add on to what Don is absolutely right. It is important, to find out why did the cable fail there? Because if it failed because of some aging defect, you might have more, like Don was saying, you might have more of it, more water treating in the cable. So, where if it failed maybe from a dig in and you have to put a splice, and you can say, well, it failed from an external cause. So the concern is a little different. But it's really very, very important to look at the two different scenarios. And if it failed because of aging, then the best would be, before you put the splice in, you test the two ends of that cable and see if you find more problems with aging in that cable before you put the splice on. And secondly, a totally different aspect of this testing with the IR insulation resistance tester is, in my opinion, it is not very useful to test a cable to just acknowledge it can be switched in without a risk if you test it below operating voltage, because the moment you switch it in, it sees at least operating voltage, and that is a problem with the IR tester, because it's normally limited to 5 kV, and that doesn't give you enough to even come up to the peak of operating voltage. So I think always any test that you do to confirm operational readiness should be at least done at the peak of the operating voltage.
Thank you, Henning. The next question is actually a live question and a follow-up to a statement that Henning had. This is actually from Timothy Connolly, so he is online. And Henning, with regard to Henning's answer of using high pot, what method of high potting is he referring to?
Well, I think it was probably to the comment about the different technologies in VLF testing, where we have the sinusoidal 0.1 Hertz technology and we have the cosine rectangular 0.1 Hertz technology. And both of these VLF AC high pot test methods are described and in the IEEE 400.2 standard. So they can be used both, and in the same as in IEC standards, they can be used both. And you will find, the exact test parameters are listed in these standards, with the one caveat, that in the IEEE standard, if your test equipment is not capable enough, it allows you to go to a lower test frequency. And that is something, it's not recommended in IEEE, but it's permissible. Where in IEC standard, it's not permissible. You have to use a 0.1 hertz because the test results will be different at a lower frequency, like 0.01 hertz. So I was referring to these two different VLF technologies. I hope that answers your questions.
Our next question is actually another live one, and Hein, this will be from you. The question was from Andrew. In asset management point of view, is it necessary to do VLF, PD, and Tan Delta tests to help decide whether to replace or not to replace aging cables?
So if we look to aged cables, then we are talking about old cables. And over there, I again compare it with going to a doctor. So if you want to have your health assessment of your personal body, then there are 3 ways. You can do your a blood scan, you can do some other tests, and you can do, for example, a running test. And if you have heart problems, then running is not the best which you can do. That's the same with a cable, on an aged cable. So VLF testing or HiPod testing on an aged cable, it depends on the utilities policy or testing strategy. But if you know that the cable is already very old, then you do not really want to overstress it. So on aged cables, we normally only recommend a partial discharge diagnosis and a Tangens Delta diagnosis. And based on those test results, you can then decide if you additionally want to do a VLF test as well. So normally a PD test and a Tangens Delta measurement is more than enough. If you want to do a VLF as well, then only do that on the cables which have a low Tangens Delta value, so which have low losses, to be absolutely sure that you don't have a high number of breakdowns because you have a critically aged cable already. So from the asset management point of view, summarized, if you're talking about aged cables, you at least need partial discharge and Tangens Delta to get a complete assessment of your cable. So PD, local problems like Don already told, Tangens Delta, global issues, so aging of your insulation.
Thank you.
Jay, this would kind of tie in with what Don and Henning referenced as well from a repair of a cable, but we've experienced if you have a fault of a single phase cable in a 3-phase system, we want to check the integrity of the other 2 cables. So we may do a withstand. We'll definitely do a Tan Delta, and we may do a withstand before we decide to repair just that one cable in that system. So that's been a great performance metric for us.
Thank you both. All right, we have another live question, and Hein, this will be for you. It's from Ahmed. It says, for serviced age cables, if the TD test is okay, the Tan Delta test, do I have to perform partial discharge test, and why?
Yeah, so unfortunately, that's a yes. So a Tangens Delta measurement is only a global measurement, so it only gives the indication about the condition of your insulation. If you have local problems or local damage of your cable or local problems in your terminations or splices, then in most cases you don't see them with a Tangens Delta diagnostics, and then you need to do a partial discharge diagnosis. So that's the main reason that on service age cables you need to basically test both. On new cables over there, we normally only advise to only perform a partial discharge diagnosis. Yes, you can do a Tangens Delta measurement to get a fingerprint as well, but over here it depends on the type of insulations you have. So there are several types of polymer, so XLPE cables. It can be a homopolymer or a copolymer cable, and depending on the type you have, then the Tangens Delta results can be misleading. So over there, we say if it's new, why test? You can start after 5 years or after 10 years when the aging is really starting, but that depends on the local testing strategy as well. So normally new cables only PD, aged cables PD and Tangens Delta.
Okay. Any other comments? Okay. So with that, we will move into the partial discharge testing. Our next question is going to be for Darren, and This is, can the results be integrated into my GIS system?
Thanks, Shay. Yeah, I mean, the simple answer to that is yes. You know, and most likely they should be too, you know, to have that condition analysis. I think Patrick also, he mentioned, you know, that he's doing he has a statistical rehabilitation plan. He didn't say those words, but it was, you're using statistics to work out where you should rehabilitate first. So yeah, they should be integrated into a GIS system, possibly into a work management system, your asset management system. I even think of, there's a lot going on when I think about utility analytics and just predictive maintenance within systems as well. So the results simply, yeah, they can be integrated, of course, and you know, all of the diagnostic condition analysis, whether it be global, as Hein mentioned, or whether it be local defects from you know, just the partial discharge analysis, all of that can go into, along with coordinates, of course, and structure numbers and all of the above, but all of that could go into a GIS system. And then, like I said, I was really interested in Patrick's answer where he's doing some statistical analysis, which could be risk of failure on where you should actually go to rehabilitate based on the condition first. So, you know, your work management systems and all of that. But I know that predictive maintenance, for example, is really strong right now. Using data to analyze external events, for example, you know, like load or lightning strikes, transient causing defects, along with taking a look at age of the system and history of prior faults and all of this external data that you have that's helping you make decisions on how to rehabilitate based on the condition. And Hein touched upon condition too. It's one thing to get the condition, but then it's something, then you have to make a decision on the results of the condition. And it's the same with the human body. You're exactly right. It's one thing to be told that you have an issue, but it's another thing then to deal with the issue. So yeah, that's kind of a long answer.
Go ahead, Pat.
And Shay, thanks. Darren, I completely agree. And we don't do the partial discharge on our system, but we do pull the Tan Delta results and we attach them to those sections of underground cable that we've tested. And so when we do get multiple tests, we start to see those trend lines for that cable section or that area of cable or that vintage. So yeah, it's very simple to attach it to your GIS system.
Yeah, I've even seen, you know, we talked about predictive analytics and being able to look at a risk of failure, but you can even look at impact of failure too. You know, you could have two cables that test exactly the same, but one is more critical than the other. So you can look at impact of failure and how that acts with your metrics as well. So.
Thank you both. Next question is going to be for Hein. This is from Rathish Kumar, and it was how to interpret the fault using partial discharge.
Yes, so looking to a partial discharge diagnosis, then you normally have a outcome, so a number. So if it's a new cable, then it should be PD free. So then it's easy. If you're talking about aged cables, then it's not only your PD level, so you also take into account, is this a critical cable, yes or no? If it is a critical cable, then you change your PD levels. Then another point is the history of your cable. So did already had a number of faults on this cable? If yes, then I also recalculate the value. Then if there are accessories within that, so splices within the cable where you know from that they are showing a higher number of defects, then in that case you can lower your PD level again. So it depends on quite a lot of factors, but first of all, if there is PD, it's in most cases not good. And then depending on the other factors, you can decide, do I need to replace or do I not need to replace? So that's the point about PD. And it should be localized, of course. So that's what was one of my prerequisites. If you're doing an offline PD test, you know where it is coming from. Is it coming from the termination or from the splice or from out of the cable? And based on that, you apply your other rules to interpret or to make your evaluation and recommendation on the cable itself.
Okay, thank you. Our next question was from a registrant. This is going to be for Don. It's from Constantine, and it's if you found 2 or more partial discharge locations in the cable, how to determine which type of PD source in each location?
Yeah, I think thinking in terms of this question that we're talking about location essentially. So the offline partial discharge test system consists of location by determining the origination of the fault by a TDR principle, or time domain reflectometry method. So by this method, you can locate and then map where the discharges are coming from. So you actually create a map by first determining the electronic length of the cable, and then knowing where you're testing from and where the other end of the cable is and where any splices are, they're likely culprits of discharges. So knowing that information and putting those distances into the software when you begin the test helps you determine where the location origination will be by that TDR principle. The way I like to look at it, it's like the fault is like placing the TDR in that location, and that's how the pulses arrive at where your measurement point is. And if you have multiple locations where that's occurring, the map will populate and fill in those locations for you.
Okay. All right, thank you. Done. Okay, so next question is going to be for Hein, and this was from one of the registrations. Wang Fu Lo, could you please advise the method to accurately measure partial discharge for medium voltage cable enclosed by metallic cable cover?
I hope I understood the question correctly. So what you always need to have to perform PD measurements on your cable is access to your cable termination. If that's not possible on one side of the cable, you can still go to the other side of the cable and then perform your test. So if it's on one side enclosed by a metallic cable cover or by a cover which you cannot remove, but still still you can remove it from the width, then the best would be to test it from the other side. So over there, if that is meant with enclosed by metallic cable cover, that's basically the solution. Look to the other side of the cable. Can I connect on that side easily? Then test from the other side and perform your test. That's basically my answer on that question.
The next one is going to be back for you, Don, and it is, what is essential for good PD measurements?
Well, I think of online a little differently than the offline tests. So thinking of online, it's certainly elimination of noise, which isn't so easy because the cable acts as an antenna, and in operation, it's connected to sources of noise often, thyristors and inverters. So sorting out and determining what is noise and real PD is probably the #1 concern. So there's different ways of doing that based on if the signals are synchronous and the waveforms and that sort of thing. So then looking at the other side for offline PD testing, it's a lot easier. You don't have to deal as much with noise. It's not nearly as much concern as it is with online PD testing, and that's because I can control the voltage. So I can take my measurement with no voltage present and determine my background noise, and then I know as I'm increasing the voltage that anything that's developing is only associated with the partial discharge. So in offline testing, I tend to be more concerned with my setup and elimination of corona in order to obtain accurate measurements.
Okay, thank you, Don. Go ahead, Hein. Yes.
That's correct. So if we talk about offline measurements, then essential is first of all a good earth. So if you have a bad earthing, then you normally already have a higher noise level. And then the second point is a proper connection to your test object. So Don was already talking about corona. So that's the same with that's what I meant with connection to your test object. So you need to have the correct adapters to have a PD-free connection to your cable to perform good PD measurements. If you've got a bad connection, if you already create PD at your elbow, then you basically cannot assess the condition of that elbow. The rest of the cable can still be assessed, but of that elbow itself, not anymore. So essential, good earthing, and also a good connection to your test object.
Thank you both. All right, we have a live question, and Hein, this will be from you. It's from Mohammed. Can a PD test add value to testing old cables? My understanding of PD testing is that it is more a comparative test than Tan Delta diagnostics.
Yes, the PD test adds lots of value. So it's not a comparative test. So with the PD test, you are focusing on local issues, which you can also have on old cables. So your cable can be perfectly in good condition once it was put into service or when it was completely new. But if you're overloading a cable, it could be that you are having increased temperatures in your splices and they are degrading and finally also creating PD. And then with PD, you can localize them. Whereas with a Tangens Delta measurement, you only see that you have a problem, but you do not know where it is. So a PD test on an old cable is essential. So both PD and Tangens Delta are recommended because of the two different aging phenomena.
Okay. And we have another live question, and we'll go to you, Don, and this is from Matthew Kakura. And I'd like to know the best way to test 35-year-old 3C 500 MCM 5 kV motor feeders.
Okay, motor feeder. So yeah, 35 years again, we come to that situation we talked about earlier that this could be unshielded cable. And so we addressed that earlier. So we're assuming that it is shielded, and being that typically you would think that a run to a motor would be relatively short, I'd probably be more concerned of that cable, the bulk insulation of the cable myself, and doing the Tan Delta would be good for that, certainly. And then as Hein pointed out earlier, well, what about the terminations essentially? And will that VLF Tan Delta show any defects in terminations? And in that case, it would be best to also do a PD test to determine the integrity of those components.
Thank you. Yes, Hein, go ahead.
One comment. It says 3C. So I would think the gentleman is talking about a 3-core cable. And once we talk about 3-core cable, then we have also the issue of potentially having belted cables. And I just want to say, you know, belted cables or unshielded cables have very different, require different principles and different techniques to do any type of cable testing, if it's even possible. Okay, so I just want to mention that, because it says 3-core cable. Okay.
Then from my side, so it also depends, can I disconnect them from my motor, yes or no? So if your motor is still connected on it and you do a Tangens Delta test or a PD test, then it doesn't help you in that way. So that's, I came to this in nuclear power plants. So if they are within the forbidden area, then it's hard to take the cables out of the, or remove them from the motor. In that case, it will be hard to test your motor feeder. So also that can play a role. So you need to have a complete picture of your cable. Can I completely detach it? What is the type of cable? Is it belted, non-belted? And if you have all that information, then we can give you a recommendation of what is possible on such a 5 kV cable. No?
Thank you. All right, Hein, we have another question from the audience. Do I need to be an expert to perform PD measurements?
That's a good question. This is also where quite a lot of utilities have fear from, because they think it's black magic. So if you talk about partial discharges, then hair is standing up. So in my case, my hair cannot stand up anymore. So I've seen lots of PD here. In the past, the partial discharge diagnostics was really for experts, but nowadays the technologies are improving and also the software is improving and also supporting the end customers. So now I would say you do not need to be a expert to perform partial discharge measurements anymore. So evaluating the data as well as performing the measurement, you get support over there. As long as you have a good connection to your test object, if the grounding conditions are okay, then everybody can perform a PD measurement. So it goes now even in a way like a Tangens Delta measurement that you only press on the start button. Please do my partial discharge measurement, and then you can sit, drink your cup of coffee, and wait until it says please connect to phase 2. So we are getting in that direction already to just give an indication of what is happening in the PD world. So it becomes easier and easier, and you certainly do not need to be an expert anymore.
Great.
Yeah, I'd like to add to that. Yeah, I think it's easy when everything tests good, and you're confident you're connected to the cable and you're not just testing air, right? So then it goes back to what Heinz said. Once something goes wrong, or once you detect something, then it becomes a little bit more of a troubleshooting operation. That's where the experience does come in. And so, as Heinz pointed out, you need to make sure your test set is connected right and rule that out. So there's some thinking that goes that's involved once you spot something. If it all tests good, then anybody can do it. When something comes up, you got to think about it a little bit, of course.
Okay. Yes, Heinz, go ahead.
I have 2 kids, and I sometimes compare it with my kids as well. So now they are in the age they are starting to learn cycling. So I'm from the Netherlands, so that's where lots of bicycles are. So if you start to learn cycling, then they first need to gain confidence. And once they gain confidence, then they also then they know those situations where they need to pay attention to. So it's like cycling. The more tests you do, the more experienced you are, and then the more confident you are in making the PD measurements as well. So it's also like fault locating. If you do a fault locating for the first time, you think, oh, where do I need to look to? If you do it day by day, then it's just a fault. No?
Thank you both. All right, we kind of a follow-up to that question. So Hein, we'll come back on to you. It's from Luis Balderas. And what are acceptable PD values in picocoulombs during test in the field and medium voltage and high voltage cables?
That's a very good question, and it's also not that simple to answer. So there are, compared to a Tangens Delta, no standards or guidelines available that gives you acceptable PD values in picocoulomb for field tests. So what I told before is that if the cable is new, then you know that it needs to be PD free up to a specific voltage level. So over there, things are easier. If you're talking about aged cables, we also know that if it is in the accessories, that they can withstand some partial discharges, so that you do not need to replace them when they already have 20 or 50 picocoulomb. They can still stay into service for a longer time. So over there are threshold levels which where there are recommendations coming from the manufacturers, and where there are also recommendations coming from utilities with their own practices which they're using, and that's where everybody is getting support in the beginning. But normally you should basically build up your own knowledge database, and as the start, you have those threshold levels coming from the manufacturers, which is a summary of all utilities worldwide.
Okay, thank you, Hein. The next is actually a live question. And Don, we'll go to you. This is from Ahmed. For medium voltage cable online PD testing with one side from main medium voltage switchgear, what's the best practice? Using capacitor voltage inductor or HFCT on the shield of the cable?
The capacitor sensors are generally used for switchgear or something very localized for the application and how I use the technology. So I would always use the high frequency CT, and my thoughts would be, whenever possible, I would like to also do that test from the other end of the cable. The reason is the partial discharges, as they go down the cable, they attenuate, and the frequency drops, the rise time or the of the pulse drops and reduces to, so a distant PD source is going to likely fall down into the noise level and make it a lot harder to detect. So I like paying attention to the frequency where I'm of the signals that I'm receiving at the location that I'm at to try to verify that. So I would always like to try to get information from the other end of the cable as well for online PD testing.
Okay, thank you. Yes, Hein, go ahead.
It's me again. Yeah, so I've already within the first questions I was talking about the VDS voltage detection system. So I think this is where Abed is also referring to. We have experience, but it depends on what type of VDS system you are using and how it has been cabled within your switchgear to see how far you can look into the cable. So if you've got a long cable, then certainly the VDS will not be the best. But if you have shorter cables below 1 kilometer, then also the VDS systems, depending on the type you have, can be a good alternative, especially if you then do not need to de-energize the cable. So that could be one of the main advantages of using those voltage detection systems, to not de-energize the cable itself and do the test in service without switching.
Okay, and we have another live question. Henning, this will be for you. Instead of VLF tests, can you do partial discharge testing? Are they equivalent? And that's this from Alexander.
Very clear answer. They are not equivalent because they give you different answers about what type of defects you might have. Now, there is a little overlap. You could have a condition that causes PD that also would react to a VLF test and would react to a VLF test, not Tan Delta test, to a VLF test, to a HiPod test by failing, okay? Because if you have because you typically do the VLF test at a much higher voltage than you do the PD test. So if you had PD at the PD test voltage level and you go to 2.5 or 3 per unit test level for VLF testing, instead of having a little bit of PD, you could have a lot of PD on avalanche and you could get a failure. Okay, so these two tests are not really interchangeable, and you know, don't give you the same answer. So it's really important to sort this out and determine what is it. Am I interested in what other panelists had already mentioned? PD test is typically a very good tool to find problems in splices and termination accessories, and the VLF withstand test is basically also like any HiPod test. It only can find the worst spot in the cable by basically failing it. Okay, so that's why the VLF test as a HiPod test, as a withstand test, is typically only used as an additional test method, but the primary test method for the cable itself, for the aging condition, would be the Tan Delta test, and in combination with the PD test for the termination and splices.
Go ahead, Pat.
Yeah, and Shay, I agree with Henning, and I would just say from a user perspective, you've got to be prepared for the results of a withstand test, right? A diagnostic is going to give you an output. A withstand test is going to give you a go, no go. If it doesn't pass, you're going to have a faulted cable that you have to address. So you have to be prepared for those results.
Thank you both. Okay, so on to analysis methods and criteria. The first question will be for you, Hein. It's from Mohammed, and it's how to interpret the results of different tests.
So if we look to all the tests which we have discussed already, so could be an IR test, could be Tan Delta, could be partial discharge. It's a combination. So if you want to have a complete assessment of your cable, then you need to pay into account to the Tan Delta measurement and to the partial discharge measurement to make a complete evaluation of the cable itself. If you only do one test, then it could be that you oversee some issues. So the combination basically of TD and PD gives you a way to interpret it, the result of your different tests. So there is not a maybe Mohammed is meaning that there is a tool where you can add a factor for PD, where you can add a factor for TD, or where you can add a factor for IR testing or other tests. That's something that a utility can make, of course. So I know that utility in Malaysia is having something like that, where they make their own criticality factor for a cable based on the different tests they perform, and they have weighting factors for each type of test. So if Mohammed is meaning this with this question, then yes, that's also a possibility to get one number out of different tests for your cable by using weighting factors for each type of test. No?
All right. Next question is going to be for you, Henning. It came in from a couple participants, Nicholas and Daniel. Differences between cosine and sinusoidal VLF testing. Can both wave shapes be used for PD testing?
Yeah, both wave shapes can be used for PD testing, and that's written up in IEEE 400.3. But there are differences. And you know, the fundamental principle of PD is when does the inception voltage happen? When you get PD, and that inception voltage is frequency dependent. So the higher the frequency, the lower the inception voltage. So when we look at the cosine, at the sinusoidal 0.1 hertz wave shape, the frequency is 0.1 hertz. Where if we look at the cosine rectangular wave shape, even the overall frequency is 0.1 hertz, but the more relevant frequency of the change in polarity on a cosine rectangular wave shape is power frequency. So it's basically the same, you know, in the millisecond range. And so, what it leads to is that certain defects, especially in those in termination and splices, will show lower inception voltages with a cosine rectangular wave shape compared to the sinusoidal wave shape. And that can be problematic, because if you have PD and you find it maybe on a sinusoidal test at a voltage level, let's say 1.5 U0, you might not be very concerned. Where in reality, if you go to power frequency or to cosine rectangular wave shape, you would find maybe this inception voltage at operating voltage or even below operating voltage, which creates a big concern. So that is the basic difference between the two wave shapes when it comes to PD testing. And the cosine rectangular is very similar to its characteristics regarding PD, like power frequency 50 or 60 hertz. And also the other wave shape, it's basically also an AC wave shape, was mentioned a few times, DAC, damped AC, which is basically also at power frequency range between, let's say, 20 and 300 hertz. So all these power related frequencies, they are overall better suitable to find all defects, PD defects in cable systems compared to the sinusoidal.
Thank you, Henning. All right, we're actually going to come back to you again, Henning, and this is again from Nicholas. PD and paper and mixed medium voltage cable lines, is it necessary to perform any test?
Well, if you have mixed cable lines, you have one element in there that can be a big cause of problems, and that's what's called a transition splice. So it's very important, you know, when with the advent of the solid dielectric cables, the first transition splices came in the market, and there were a lot of problems with those failing, because it's a much more complicated splice, because you have the oil stop in it on the one side, and you have to splice it in with the solid dielectric. So it is a very good test to do a PD test, because many times your problems are in the transition splices, and so yes, the answer is certainly, it's one of those applications. It's probably the best tool you have to really assess the quality of the transition splice, which could be a source of big trouble in your circuits.
Yeah.
Yes, Don.
Oh yeah, I agree with Henning, and also wanted to point out, just for paper insulation itself, there's been a lot of success in the UK monitoring the paper type insulation, and some of that sort of self-heals. It varies with temperature. So unlike some of the other cables, it can vary quite a bit. The paper cable, that is, with temperature variations, and it sort of has a little bit of a self-healing effect. And so when it gets warmer, the oil can migrate a little bit and vary that PD. So they had a lot of good success monitoring the cable PD there.
Thank you both. Okay, so the next one's actually a live question, and Don will come to you. This is from Mohammed. Is there a standard on minimum insulation resistance for a cable? Is it sufficient to perform an insulation resistance test and VLF high pot test?
Yeah, there are standards. I'm in the U.S., and so there's standards I keep within reach. You know, the ANSI, NETA-ANSI standard for acceptance testing, and they also have a companion standard for maintenance testing. So we test every day, and I use that guide constantly to look up various values. And it's a guideline, of course, but it's a very good guideline. And just like I know Einstein couldn't remember his phone number, so that's why I don't remember everything in here. So I can look it up though. So it's always within arm's reach.
All right, yeah. Henning, did you have a question or a statement?
Yeah,
I'm sorry.
well, maybe as a little add-on to it, you know, the question is it sufficient to do IR test and a high pot test? Again, you will find certain defects by using these two methods, but you need to establish, to know the entire condition of the cable. Then it will not be sufficient to do that, because the insulation resistance test is only stressing at a much lower level because of the test voltage, and the high pot test is basically a go no-go test. It finds the weakest spot in the insulation, but if you have one really weak spot which will maybe fail, that's what will happen. So you have to fault locate afterwards, and you have another spot that's almost as bad, you will not see it. Okay, so that's why in my opinion, it's not sufficient to do these two tests to get a good assessment of the insulation condition of that circuit.
Okay, thank you both. All right, we have another live question. Hein, this will be for you. It's from Bryce Priest. Underground 69 kV XLPE cable. We have several reels of miscellaneous spare reels of this cable, most of which are more than 20 years old. They have been stored outdoors the entire time in the desert environment. There is no baseline historical test data for any of these reels. Is there any practical, reliable test that could be used to ascertain the condition of these spare cable reels?
It's a good question. It's a hard question. So yeah, the first test is of course the visual inspection. So do you see any damages caused on the outer jacket caused by how do you call it, by sun, by ozone, by sunlight. So if there's already some aging, then you know, okay, there, if I put it in the ground, then it could be that I get lots of moisture in my cable. Sheet testing on that cable is in most cases not possible because there is no return unless you have a outer semiconductive layer. But if it's already 20 years old, it will not have an outer semiconductive coating on the outer jacket. So the only test which remains would be a partial discharge diagnosis but also over here, if it only has been stored outdoors, I do not really expect that there will be lots of PD testing. So it will go more into the direction of a TDR test to see if there are any in common or not normal reflections which you can see on your TDR. But so PD test does not really make sense. Sheet test is in most cases not possible, or you must put a cable in water, then you can do a sheet test. The Tan Delta measurement will not make any sense because the cable did not age, only from the outer side, so it will mainly be visual and a TDR test. That's what comes up in my mind. I do not know, Henning, what do you think?
Well, actually, I have two brief notes on this because we participated in a cable test one time with General Cable when it was General Cable in Texas, and this was a very interesting test because they had service age cable retrieved from utility companies, and that was the exact same batch number that they had still at the factory in Dallas, in Texas. And those reels had been sitting outside for about 15 years. Very similar to your situation in Arizona. And so everybody thought that the service age cables, they would show up worse than the cables that were just sitting on a reel for 15 years in the bright Texas sun. And everybody was surprised to see that those cables that had been sitting outside, had not been in operation, were aged much worse than the cables that had been buried in the ground and under load. So, and a lot has to do with what Hein was alluding to, the ultraviolet radiation, because all these materials, these, let's say, solid dielectric materials, they will age with UV radiation. The temperature changes, so there is a lot of mechanical stress being exercised, right? And environmental stresses. So that was one situation. The other one was in a chlorine plant up in Canada, where they had all also solid dielectric cables. They were not buried, but they were run on cable trays. And those cables, after we did some testing after 25 years there, and they all turned out to be end of life because the biggest aging factors, the two biggest aging factors were the constant change in temperature from night to day and also the UV radiation. It had basically deteriorated the insulation very, very substantially. So I would be very careful to do anything with those cables and installing them in a new circuit.
Okay.
Yeah.
Yes, go ahead, Dan.
Yes. So I guess the other point, going along with that, is that, as you mentioned, it was very hot in Arizona, of course, in the desert environment, but they're also on a reel. So if you test them on the reel and they test good, and then you stretch them out, if the insulation is brittle and so forth, what's that going to do to the installation? So you'd probably need to repeat that test after installation, and certainly as a minimum, but maybe you just wasted a lot of time installing those cables in the first place. So will it rely as well after you install them, after it's been aged on a reel for 20 years? It would be a possible concern also.
Okay, and Pat, you also had a question or a comment, I'm sorry.
Yeah, we have run into this from a utility perspective as well, right? So you either have partial reels from installations, or you have that reel there for emergent restoration, right? And if it's been there for 20 years, that's a risk assessment now, just as everybody said. But on the other side, you kind of got to swallow hard and figure out, well, do you want to take a 20-year-old cable or have 20 years of advancement in cable technology as well? So that's a lot of investment there. So it's definitely a risk assessment at that point.
Thank you all. We have reached the hour-and-a-half mark, but we're going to go ahead and ask a few more questions before we cut off. So if you'd like to stay around, maybe 5-10 minutes. The next one is going to be for you, Pat, directly. There was a question from Jesse Darrell. Why you guys moved away from DC testing?
Oh, well, all the experience with DC hypot testing and the space charges and the damage that we've learned that it can do to the cable. So we've moved to a VLF Tan Delta diagnostic testing. And I'll certainly let the experts weigh in here.
Okay. Hein, did you have something? Go ahead.
Yeah, so DC testing is on new cables, it will not damage your cable, but you will not find all problems within the cable. That's also nicely written within the IEEE, and there are also lots of papers published about it. So if you've got a cut in your polymer insulation, then with a DC test, you will not bring that problem down to a failure. So it is a critical issue, but with a DC test, you don't break it down. So that's why DC testing on new cables is not really recommended anymore. And on 8 cables, on the other hand, we have the issue with space charts. So if you do a DC test on a water treat XLPE cable or a PE cable, then you can cause more problems afterwards when putting the cable back into service than it was before. So DC testing is not really recommended for cables anymore. So you can still perform it on paper cables without any concerns about damaging the cable, but the same with like with XLP, also with paper cables. If you have really moist sections, then with a DC test you will see it with a leakage current, but you will not really break that problem down. So and as in most cases you have mixed cables, you have a VLF test set anyhow. So if you have it, I would also test the paper cables using a VLF instead of DC. And especially if you have the Tangens Delta, then you have an alternative for your leakage current as well.
Thank you both. All right, next question is going to be for you, Hein. This is from Mule. What does standard deviation values during a Tan Delta test indicate? What is the cause for standard deviation being high? How to interpret?
So that's a good question. So for those of you which are not familiar with standard deviation, the standard deviation basically means how stable is my Tangens Delta at the same voltage level. So I take 10 readings at, for example, operating voltage. If all 10 readings are the same, then the standard deviation is low. If you have a situation where, for example, at the beginning the Tangens Delta values were high, but during your over the range of your test, the numbers are dropping within the same voltage level, then that's a high standard deviation indicating moisture in your cable. Another way or another high standard deviation could be when having PD. Then it could be that you have high losses, then lower losses, higher losses, lower losses, higher losses, so it will hop around, so it will not be a stable value, then it's an indication for PD. And if it goes from down to up, then there is a problem upcoming. So the standard deviation gives you more information about the type of defect you have in your cable.
And maybe just to add on, that's why it's written up as a third criteria in IEEE 400.2 on Tan Delta measurement, because aside from the absolute Tan Delta, aside from the delta Tan Delta, the standard deviation is a third criteria, and all 3 criteria need to be met to assess the cable. So it is a very important criteria, because like Hein was saying, if it's not stable, that means there is an issue in the cable.
Okay, thank you both. So the next one is actually going to be for you, Hein. This is from Alfredo. For direct buried underground 500 MCM 35 kV XLPE cable with armor, how many years before replacement?
That's the lottery question. Huh? So if I would have been able to give an answer for that, then I would be a millionaire now, because then I can design a cable for a specific lifetime, but it's not possible. So that's the same like myself. So if I go to a doctor, then I say, okay, if you do the same like you are now, then you can become 100 years old. But if you are drinking a lot, if you take drugs, if you're driving 200 kilometers per hour on a highway, then I do not think you get that old. So it depends on your loading conditions of your cable. So Henning was already telling one thing with the outdoor cable drum. So do I have a stable load, or do I have a load like a wind farm, high load, low load, high load, low load? Am I overloading my cables? Have an influence on your lifetime? Do I have a moisture environment? Do I have sheet faults, etc., etc.? So there are quite a number of effects which play a role in the aging of your cable. And that's why it's not possible to give any lifetime estimation. Therefore, you need to do the diagnostic testing. So if you do the tests, then you know the condition at that moment and you can monitor it over time. But to give a year for, so if you install a cable now, I cannot tell you how long it will survive. So only by monitoring it, you can give an idea of how good or how bad your cable is. But even then, if I measure a cable of now 20 years old, it can be in perfect condition. I cannot say that it will survive for another 20 years. It could also be for another 30 years. If you have the same load, if you do not overstress it, the cable will not break down. So it depends on how you handle the cable.
Great.
Maybe one comment. You know, the fact that this cable has armor. The armor doesn't enhance any of the dielectric properties of this cable. The armor is purely a mechanical protection, which is good in certain applications, especially submarine cables many times have armor on them. But so it is purely for mechanical protection of the cable. But the aging within the insulation is not affected by this. Okay.
And Shay, I would just add to that, it would be just as important to, from a diagnostic perspective, to look at the accessories as well, right? Because your cable may be in great shape, but if your accessories aren't keeping up, that would be an issue. So.
I thank you. Due to the time that we've gone over a little bit, I'm going to end with this last question, which it is for you, Patrick. Sanjay and Ahmed, they're live. Please clarify on the minimum duration of the VLF high pot testing, 5, 15, 30, or 60 minutes?
We don't do it often, so we follow the IEEE guideline, and I believe it's 30 minutes right now at 3 times grid voltage. I would look to my panelists to correct me if I'm wrong there, but that's my recollection of what we're running right now when we do a withstand.
Yeah, that's correct, Patrick. In IEEE, the minimum on service age cable is 30 minutes, and but if you can run 60 minutes, it's always the preferred length or duration for service age cable. On new cables, 30 minutes in IEEE. I think in IEC they have now a test. I think a test duration, and Hein might chime in. I think it's 15 minutes, but on new cables, not on service age cables. On service age cables, it's because of the things that happen in the cable, the formation of trees and so on. That's why the 60-minute time is always, from a result point of view, the best you can do is to do a 60-minute on an older cable. You might cut back the test voltage a little bit if you're concerned, but you should not cut back on the test time on a service age cable.
Okay.
In some cases there in the standard, I believe you can reduce that time if you're monitoring that during that test for partial discharges, for instance.
Right. So as we wrap up, I want to thank everyone for all you guys, as well as the participants on the other side, for their participation. On the screen, you will see the company and contact information for all the panelists today. You'll have that included in the webinar. And I wanted to say a special thank you to our guests, Don and Pat, again, much appreciated.
Thank you.
Please make sure to take the survey at the end of the webinar and let us know how we did. Additionally, Your certificate of attendance and the recording to the webinar will be sent to everyone within 2 business days. Also, you can view video recordings of previous webinars as well as register for upcoming webinars on our website at us.megger.com/webinars and register for our next webinar on Friday, November 20th, Fundamentals of Motor Protection. Once again, thank you all for your participation.
Thank you.